So let's start the second session of our last project in the beginner stage. So the project name we kept was computer-based data monitoring and device control. Let me open the schematic and its associated program which created last week. This is the schematic, I think. Yeah, this is a systematic. Our idea is to read temperature sensor and light intensity sensor LDR with the help of ADC and send the data over UART via UART to computer and also receive some commands from computer. Based on the command, we have to control the relays. Okay, this is the concept, and we will be uh, doing this exercise to learn uh, whatever we uh, learned previously um, related to arrays, functions, uh, and all other basic C programming concept. Let me open that ID also, MPLab ID. So previously we faced one issue during compilation. I will explain that to how to uh, avoid such errors. So previously, when we create a project, we did a mistake. Because of that, this problem came. I will show you what is that problem. Okay, so here you can see some of the files in the project data logger contains spaces or odd characters. So you are not allowed to create project name like this, computer underscore based underscore like that. You can keep a small name without space or without underscore or special character like that. So I am removing this project, but same file I copied here main.c. You can see I copied that main.c to this source file main.c. So I am just removing this particular project from the project session. Now you can see if I am compiling this data logger project, it should compile clean and build. Yeah, it's compiling. Let's go to the code. So here what we did previously, we initialized all the ports, we initialized the ADC, we initialized UART as well, configured UART to communicate at the baud rate 9600 bits per second. Now our aim is to read this temperature and send that temperature to computer. Okay, so in our previous exercises we already did a similar thing, just we are modifying that code to achieve this new thing, reading two different analog parameters. Previously we did only one, we did reading only one analog parameter. Now we are reading two analog parameters. So we just modified our read ADC function to handle this. So read ADC function, what it does is it accepts a channel number. Based on that channel number, it decides the channel register, associated channel flags. Okay, inside this AD con 0 or 1, AD con 0, I think. Yeah, in AD con 1. In AD con 1 we have three channel flags which can help you to get the respective channel. So if it is 0, channel 0 will be selected, because in channel 0 we have temperature sensor, in channel 1 we have uh, LDR. So here you can see channel 0 means temperature. So we have a global variable called temperature. So we will get the value temperature, the value temperature here. It will update the temperature value in this variable, global variable, after executing this read ADC. Okay, so let's see whether it is working or not. So what we have to do is we just need to use this send to PC function to send that temperature value and light value to PC. Okay, so I am going to write a function again, which is send temperature. What it should do is it should send temperature. Okay, uh, previously we faced an issue during compilation. We solved it. You can watch that video uh, after uploading into YouTube. I just reached here, and right now I am trying to send the temperature to PC. Okay, after reading the temperature, I am trying to send the temperature data to PC. For that, I am going to create a function called send temperature. Okay, so I will write it over here. So this function is not going to return anything, so that's why I am keeping void over there. This function is not going to receive any argument also, that's why I am keeping void over here. So what this send temperature must do is, so there should be some software planning. Okay, there should be some software planning uh, before writing the code. We should follow something. So I will tell you what I mean by that. I am opening Paint. So at the end it is going to this data from ADC, which is being converted by the microcontroller, is going to computer, right? At the end, computer should interpret that data, and it should display in the GUI. So last week I explained we can create a GUI with different software tools like Python, LabVIEW, Visual Basic, C Sharp. Okay, so here let um, let let's imagine that our GUI has two area. In that particular graphical interface unit, we have two area where we can display temperature, and we can display light intensity. I don't remember that light intensity is SI unit, candela CD or something, so I am keeping it over here. So here our temperature should update 100 something, like it should come, and light intensity should come something like maybe I don't know the SI parameter of that, so that's what. So something it should update here. So the GUI, or that program which creates GUI, should understand the data. Then only it can load at the proper location, right? So we are following a pattern for that. So what we will do is we will send data like this. We will keep one star over here. This is for packing the data properly. We will send a star and the temperature parameter. Our temperature sensor can only go up to 150, so there will be 3 digits. Okay, so I am keeping for an example 150 degree, so it will send star 150. um, okay, we can do like this, star T 150 hash. Okay. So what GUI software, whether it is Python or in LabVIEW, read, it can take data between star and hash only, so that we can, um, it's a kind of what we say, some packing. Okay. In between star and hash, it will take the data. And the GUI software will check whether it is T. Okay, I will write the other data also. For light, maybe we can keep it. It may have four digit values. So after L, we will be sending some 1000 hash. Okay. So what GUI software will do? It will take data between star and hash only at the first. Then it will check whether it is L or T. If it is L, it will put the data over this place, and if it is T, it will put data over this place. So this is a kind of agreement between the GUI software developer and the embedded C software developer. Okay, so these two engineers should be in contact or in discussion, and they should mm, come up with an idea at the end how they are going to handle the data. Okay, so this is the one example method which I am going to use for this particular project. So we need to pack this data. See, star T150 hash. So here what I should do is I should send star at the first. So we already have a function which helps us to send characters to through serial port. Okay, so what we have to just do is just use that function. First we need to send star. Uh, then we should send other the temperature values which we got converted. So yeah, this is the result. I would like to open the previous code which we created for reading temperature. Automatic temperature controller software. Okay, so here we have that converter parameter. I will use that converter code. I explained this in that particular video. If you have doubt, you can go and watch. So yeah, this is our code. So before sending the temperature, we should update that global variable temperature with the real temperature. Okay, what read ADC will give you is the analog converted digital data. It will be varying from 0 to 1023. So uh, based on our sensors behavior, we should code this. We should code that sensor output to get the right temperature value. This is called uh, yeah. So you have to do it like this. So at the end we will have the real temperature. Maybe if you are facing 100 degree, the temperature will be there 100. Now we have to send those parameters. Okay, so for that what we can do is you need to call a function. This is the function as printf. It will convert that temperature into string. If you are using sprintf, you should use a particular function stdio.h. I think it is already there. Okay. Okay, I haven't created buffer. I have to create buffer. So I am creating a buffer with the size 15. So here it is showing unable to resolve identifier buffer. Buffer is not created yet. So created buffer. So in that particular buffer, we will have our temperature value converted to string because we are handling strings here. This star is a string. So we are sending strings to PC. Okay. Now we can write a particular function, particular for loop kind of stuff to send all these converted temperature. Maybe it will have from 0 to 150. 3 digits would be there. Let's see, we already written that. Yes, here we have. Okay. N equals 0 for buffer of n not equal to 0. So at the end of the array, at the end of this array, the value would be 0. So yeah, if it is 150.5, there would be 1, 2, 3, 4, 5. The sixth location would be space character or 0. Okay, so we are checking that and we are updating that. So here we not defined n, so we are defining n. Now that error will vanish. Now we are sending this converted temperature to PC. Now we have to maintain this packet. For that we have to send hash. Send it to PC hash. We wrote this code. Okay, we completed the code. Sorry Pavdan, I haven't shared the screen. Okay, but the entire thing is recorded. I will update after an hour. You can just watch and follow along. Is it visible now, Pavdan, the screen? Okay. Okay. So this is the code which just created to send the temperature to PC. So let's compile this code and check whether it is sending to PC. We have few warnings. For the time being, we can ignore that. That it is expecting some double kind of declaration instead of unsigned int. Now just see whether the code is working or not. I'm going to load that code properties. It should be 11.0592 megahertz crystal. Based on that, our calculation did. Software. This is the old software. We are not going to use that. This is the new one. So inside distribution default production, yeah, we have data logger.hex. Hit the play button. It sends something, but it is wrong. temperature, read ADC, light. Actually, yeah, this is the result, return result. Result will be updated into temperature. After that, we are converting the temperature. Now send it to PC, buffer fan, then hash. To test it, we will comment this code and we will write some value to this temperature. We need to check which part of our code is causing the issue. So I'm just directly writing a value to the variable temperature. There are few other debugging methods also. We will explore it. See, still it is not working. So send temperature star. We will solve this issue. Implicit conversion float point to integer. Maybe we will create they are expecting double, so we will give that. Okay, now we have the clean code. Just I want to see whether it is working in float. No, they are insisting they need double. There are some other ways to overcome this kind of compiler warnings. We can have some settings over here. We will explore that when we are in intermediate section. Okay, now let's see the execution. Yeah, we got it. 244.38 hash. So this would be going to our GUI software. Okay, now I am going to remove the command and I will try to accept the real value. So in the real case scenario, we will connect. We will be our IDE should be connected with the hardware, and we will be debugging the software with the help of an hardware called a debugger. There, you can avoid these kind of debugging methods. You can directly debug the code. Mm. Also, you can keep an eye on the compiler warnings in order to avoid these kind of issues coming. Let's stop this execution. Let's start. It is showing 0.98 hash. It should show 27. Let's go back to the code. So here channel session, after channel section I will give some more delay, maybe 100 millisecond. Also I will check the ADC code. Result left shift 8, result equal to result or ADRSL. Code seems perfect, but channel selection I have to check once more. 0 C180. Press A. Both the pin should be input. Okay, we'll keep 3. 17.11. It should show 27. I will open datasheet. Inside this ADC session, they are telling about the time required after channel selection. Okay, so configure A2D module, wait required acquisition time. So this is the point I want to check. So acquisition time they are telling in microseconds only, but we provided enough time, so I don't think that it is going to be a problem. So let's open the file of previous project. See and check. This is the wrong code, not that one. Here we are passing 0 only. It will update here. If channel value equal to 0, channel which being selected is this one, 0, 1, 2. Channel equal to 1, 0, 1, 2. Delay is also we have given after the channel section. Selection, then go slash. we are seeing a huge difference. This is not acceptable. There's some issue in the code. Configured address A, port A, edicon 0. Zero, 1, 0. I don't think this is an issue, but still I will comment this section to check. Okay, we missed something. /done. Start conversion. It is properly updating. There's some problem with the ADC conversion. Done equal to 1. go back to Radeon channel selection. AD con 0 equal to C1 means 1100 CS1. These two bits are 1 FRC ADC RC oscillator. Channel selection we ignored. Go slash done bar. It's a start bit. AD on 1 equal to 1. So should be C1 is correct. Now AD con 1 right justified. 1000, which makes all the bits 0. ADC. Seems it's proper. It's 0 equal to 0, CH1 equal to 0, CH2 equal to 0. going to replace the entire code. Failed to identify the mistake. There is another way of commenting code. Hash if 0 we can use. Yeah. So temperature equal to read etc. This will make int only. Still it is sending only one digit. Result. Okay. It got worked. The issue which we created was after configuration before calling the read ADC function, we haven't provided the delay. Just check, verify that. Just I am commenting that delay, and after that I am building it again. Maybe yeah, this is the issue. So what it actually is, um, after configuration, it is quickly configuring all this UART related configuration, then it is starting read ADC function, because there is a minimum acquisition time required after channel selection, so we should provide that. So what we can do is, inside this read ADC, just starting before the conversion, we can put a general delay here for all the conversion after channel selection. I removed the channel selection code also. We have to add that, this one. Maybe we will try to comment this code and try to use the above one. Let's see. So just now I commented this code. Now temperature equal to read ADC channel 0 be provided. So channel 0, it will take this value. There is a spelling mistake, I think, in the channel. So after channel selection, I'm providing some delay here. Let's see whether that delay is sufficient or what. Save and compile. It's not proper still. Now it is working properly. Let's see. Yeah, 95-degree it is coming. In between we need to keep T also, star T150 hash. For that we need to send T also after sending star. It should be capital T. Now the code is working. What I did is I just kept that delay which is there in the main function after this ADC configuration, because just after that configuration we are calling this. That is the thing which causing the issue, which is not properly updating the value. Now it is properly updating the temperature which we required. This is the pattern which we needed. So T95.30, we can ignore this 7914. For that you can do something here. Percentage 0.2f. 2F. Let's see whether we are getting 2-digit. No. Let's see how I coded it before. 0.2F only. Yeah, we got 2 decimal points. So star T95.31 hash. Now our intention is to read other channel as well. We will remove the unnecessary codes. So next we have to read the light. Read ADC channel 1. After that it should send light. Just we will modify this code. Now send light. Light equal to, we don't need this kind of conversion anymore because we are not following any particular light sensor. So whenever there is any proper light sensor which converts analog light value into digital, you have to go to the datasheet and you should find out an algorithm to convert that particular analog light intensity value into the proper number, like what we did in the case of temperature. Like yeah, this is what you have to do. You have to convert it into a proper value. Then only we will get the right output in the software, because the ADC is giving only the corresponding analog value. It is your duty, the software creator's duty, to calibrate it. The right word is calibration. Here it is not temperature, it is light. So there should be a variable. Yeah, it's there. Light is there. Light is equal to read ADC1. So it will come to this function. Read ADC1. Yes, it will select this channel. Then it will send the result to here. This variable will be updated. That variable we are sending here. So here we should modify to capital letter L in order to represent it as light. You can remove this %2F. You can put just %D. Now after sending temperature, we will send light. Let's see whether the light value is updating there. star T 95.31, after that star L 948. Okay, just I will increase some value to 51. Let's rerun. Yeah, it's very 311. Let's vary some more value, maybe more than 100. Yeah, L159. So the variation is happening. So you can work around this code, and you can explore more regarding this feature till we discussed. Okay, so next session, maybe next week, we will discuss how to um, read a particular command from the computer. So what I am going to tell is that we will design two switches. Once we press, it is representing on. At the other press, it is going to off. Okay, so a particular button which will stay in either state, either on, either off. Here also on, off. Okay, so this button represents relay 1, and the other button will represent relay 2. So this is for relay 1 R1, this is for relay 2 R2. So in the GUI, if you press this button, based on the status, this relay should update. So there we are sending some data from GUI to microcontroller. So we will be following some um, other packets like maybe dollar ampersand. We can start with dollar. Not, yeah, dollar. Okay, dollar. Then for on, for the relay one, we will tell R1. For on, we will send O. Then character ampersand. For off, this O will be replaced with F. For relay to dollar R2, for on O, then ampersand. Instead of O, there will be F if we want to turn off the relay. So there is a mechanism we should implement in our C code, which is called interrupt. So today's session, I wanted to discuss all those things related to interrupt. Before discussing interrupt, we have to have some knowledge related to two concepts, that is called compiling a C program, how the C program gets compiled, what are the things which lies behind uh, the compilation. So there are few things which you should understand. So these are the steps which happens inside the compiler software. So I will record a separate section and I will update in YouTube. Uh, just watch that video and come back. Yeah, I will do that before next week. So just watch this video. I will update a separate video based on this PPT. So there is one more video. This is memory layout. So both this about this two concept you should have a good understanding in order to have a good idea how interrupts work, what is happening when a particular interrupt happens. So these are the two concepts which you should know. I will upload a separate video, maybe maybe just before our next section starts.